Hi, so we are going to learn about subtopic 10.1, which is properties of waves. So basically we have two types of waves. The first one is mechanical wave. For mechanical wave, it must have medium to travel through. For example, water wave, sound wave. And the second one is electromagnetic waves. It do not require a medium to travel, but they can travel through a vacuum at a speed of 3 times 10 to the power of 8 meters per second. For example, light, radio waves. For the subtopic 10.1, properties of wave, progressive wave can be defined as wave that propagated continuously outward from a source of disturbance. So, this is the terms used to describe waves. The first one is amplitude, with the symbol of capital A, which defined as maximum displacement from the equilibrium position to the crest or trough, the wave motion. So this is the equilibrium position. The maximum displacement from the equilibrium position is called amplitude. So this is the amplitude, and this is also the amplitude. Next, particle displacement, with the symbol of small y, can be defined as vertical displacement of the particle from its equilibrium position. Any vertical displacement from the equilibrium position is called particle displacement with the symbol of small y. It can be here, it can be here, and it can be here. For the wave displacement, with the symbol of small x, is defined as distance of particle from the source of disturbance. So basically, the source of disturbance is here. So any distance from the source of disturbance, we call it as wave displacement with the symbol of small x. Next, for the wavelength, with the symbol of lambda, it can be defined as, first one, distance between two successive crests or troughs. So this is the wavelength between two successive crests, and this is the wavelength for two successive troughs. Or wavelength also can be defined as distance between any two successive identical points on the wave. So this is the wavelength between any two successive identical points on the wave. Next, for the frequency, with the symbol of small f, can be defined as the number of complete waveforms that pass a given point in 1 second. The formula for frequency is small f equal to 1 over capital T. For the period with the symbol of capital T, is defined as time for one complete wavelength to pass a given point, with the formula of capital T equal to 1 over small f. Next, we have wave number with the symbol of small k, which defined as number of waves in a unit distance. The formula for wave number is small k equal to 2 pi over lambda. And the SI unit for wave number is per meter. for the angular frequency with a symbol of omega can be defined as angular displacement of any element of waves per unit time. The formula for angular frequency is omega equal to 2 pi small f equal to 2 pi over capital T. And the SI unit for angular frequency is rad per second. This is the equation of progressive waves, which y in bracket x, comma t equal to a sine in bracket omega t plus minus kx, where y is particle displacement, x is wave displacement, a is amplitude of the wave, k is wave number, and for omega is angular frequency. So there are two types of equation of progressive waves. If the wave propagates to the left, we put a positive sign here. Meanwhile, if the wave propagates to the right, we put a negative sign here. So, another alternative forms, we can write the progressive waves equation is y in bracket x comma small t equal to a sine 2 pi in bracket small t over capital T plus minus x over lambda. Or we can also write as y in bracket x comma t equal to a sine 2 pi over lambda in bracket v small t plus minus x. So basically, we have 2 pi in bracket small t over capital T here from the equation here for angular frequency. And for this one, we got it from wave number. And v is the velocity of the particle.
Assalamualaikum everyone. Today we will learn about 1.4 particle vibrational velocity and wave propagation velocity. Firstly, we learn how to compare between particle vibrational velocity and wave propagation velocity. Velocity of particle is defined as which oscillate about equilibrium position in simple harmonic motion that generate wave. Meanwhile, wave velocity is defined as velocity at which wave crest or other part of waveform that move forward. It also defined as the distance traveled by wave profile per unit time. Can be noticed when a cloud travels a distance of one wavelength lambda in a time equal to one period. It can be shown by equation v equal to lambda over t and v equal to f times lambda. To get particle vibrational velocity equation Vy, we have to differentiate displacement equation where y equal to a sine in bracket omega times t plus minus k times x. We will get Vy equal to a omega cos t plus minus k times x. Or we will also can get Vy equal to omega sed a squared minus y squared. For particle vibrational velocity, the value is always varies with time. Meanwhile, for wave propagation velocity, the value is always constant. This is the example diagram for velocity on the spring. From this diagram, we can see that the velocity of the wave is direct from left to right. The arrow is showing the velocity of a particle on the string. We also can see that at a turning point, the particle has zero velocity. And a particle's velocity is maximum at zero displacement. Let's continue with 1.5 displacement curve of the wave. Okay, let's see the displacement versus time curve. From this curve, we get to know the displacement of any one particle in the waves at any particular distance x from the origin. We also get to know the amplitude and period from the graph. Okay, let's move on to the second graph displacement versus distance. In this graph, we get to know the displacement of all particles in the wave at any particular time. We get to know the amplitude and wavelength from the graph. Okay, that's all. Thank you.
Okay, now we proceed to question 1. The equation of a progressive wave on a string is y equal to 0.5 sine 2t minus 3x, where y is the displacement in meters, x is the distance along the wave in meters, and the time is in seconds. So, now we have to determine the direction of the propagation of wave. When we have to determine the direction, so we have to look at the sign. When the sign is negative, so our direction is to the right. A, our direction is to the right. B, amplitude. Okay, from the equation here, we look at the first one, 0.5 is equal to 8. Right, so amplitude is equal to 0.5 meter. Okay, C, the frequency. Frequency is equal to 1 over t. So now we look at the equation here. We didn't have any information about the frequency, but we have 1 over t here from the omega. So we use this equation to find the frequency. Omega equal to 2 pi over t. So omega is equal to, omega here is equal to 2. 2 is equal to 2 pi over t. So 2 is equal to 2 pi times with 1 over t. So 1 over t is equal to 2 over 2 pi. So 1 over t is equal to frequency. Frequency, so use the calculator, is equal to 0.32 Hertz. Okay, D. The wavelength. Same to the frequency just now. From this equation, we didn't have any information about the wavelength. So, but we have the K. K is equal to 2 pi over lambda. So, K is equal to 3. We write down K is equal to 3. 2 pi over lambda is equal to 3. So, lambda is equal to 2 pi over 3. We use calculator to calculate. 2 pi over 3 equal to 2.09 meter. Okay, now we proceed to the wave velocity. The wave velocity is equal to the frequency times with the wavelength. So here V is equal to F times lambda. So V equals to 0.32 times 2.09. V equal to 0.67 meter per second. Okay, now we look at the last question. The particle vibration velocity at x equal to 2m and t equal to 1m. We know that we have to find the particle vibration velocity is equal to Vy, this equation, this formula. So we substitute all the information into this. So Vy is equal to 0.5 times with omega 2 cos 2 omega. T is 1 and minus K is 3, X is 2. So we use the calculator to calculate. So we get 0.67 m as negative 1. Yes, we settle. That's all for question 1.
Okay, Bismillahirrahmanirrahim. Okay, for question 10.1, question 4. A stretched string AB vibrate transversely at stationary wave are produced. Notes are found at point A, B, C, and D, shown in figure 10.2. At the particular instant, a point X between A and C move upwards. So they talk the point at the X between A and C moving upwards. So we go to the question A. Sketch a shape of the string AB after a short time interval and point X is still moving upwards. So that they give us a hint that vibrate transversely. Transversely wave is just like the sine graph, just like this. Yes, like this. Okay, let's we proceed. So the first one, A to C, is go upwards, so they go to the top, and then C to D, they will go to the bottom, and then the last one, D to B, they go to upwards backs. So just like this. Okay, we move to the question 2. Question B, state the direction of the motion of point between C and D. So as we can know, C and D is go to the bottom, so the direction is go downwards, just like this. Okay, and then the last question, question C, the string vibrates at frequency 5 Hz if AC equal to CD and equal to dB is equal to 20 cm. Determine the speed of the progressive wave traveling along the string. Okay, and then the as we can know, we can use the formula F equal to we can use the formula V equals to F lambda, just like this. Okay, V equal to F lambda. The formula is V equal to F lambda. Okay, I will write it properly. V equals to F lambda. Okay, just like this. So the first one, we know they want the the speed. So the first one, we have to know the length between nodes. So we can do the length is 20 equal to, no, I can write it properly. So 20 equals to 20 cm. For 20 cm, okay, 20 cm is equal to lambda over 2. So we can find the lambda. So we can find that lambda is equals to 40 cm. Okay, just like this. Okay, and then we use the formula v equal to f lambda. So v is the is the speed. So f lambda, f is the frequency. That we know the frequency is 5 hertz. So 5. So I can do like this. That's 5.0 hertz times the lambda, as we know, like that, 40 cm. So we can get the answer is 200 centimeter per second. Okay, so we can do we can get the answer. The v, the value, the speed is 200 centimeter per second. We use the formula v equals to f lambda, so we can get the answer is v, the speed is 200 centimeter per second. Okay, that's all from me. Thank you.